Okay, so in this question we're given a parametric equation, x equals sine squared t and y equals 2 tan t. And part A, we need to find dy dx, so we need to differentiate it. And that's going to involve parametric differentiation. Part B is going to involve y equals mx plus c. So let's begin part A. So dy dx will equal dy dt over dx dt. That's the parametric differentiation formula. So we need to differentiate each of these with respect to t. So we'll do the y one first. So we get dy dt, and that should equal 2 sec squared t. And then dx dt, and that will involve the chain rule, but we can do the quick chain rule. So the 2 comes down, so you get 2 sine t, and you minus 1 off the power. And then you differentiate the inner function, which is a sine t, so that gives you cos t. And then we can substitute both of these into the formula. So we get dy dx equals dy dt, which is 2 sec squared t over dx dt, which is 2 sine t cos t. And we can simplify this. The 2's cancel. And we have a choice here. We can bring the sec squared down as a 1 over cos squared. So this will give us 1 over sine t cos cubed t. Or we can just bring everything onto the top. So a sine at the bottom becomes a cosec on the top. And a cos cubed at the bottom becomes a sec cubed on the top. So either one of these is the correct answer. So part B, we're told that there's a tangent to the curve at the point where t is pi over 3. And let's just draw that. So for part B, it's not important what this really looks like, so I'm just going to just draw a random curve like this. And there's a point over here, say, and this corresponds to where t is pi over 3. So that's when t is pi over 3. And we need to draw a tangent, so here's the tangent. And they say that this tangent cuts the x-axis at the point P. So P must be this point here, the x-intercept. And they want us to find the x-coordinate of P. Okay, so to get the x-coordinate, we had better first get the equation of this straight line. So this is going to be y equals mx plus c. So we need a point and a gradient. We can plug t is pi over 3 into the derivative to get the gradient. So I'm going to plug it into this one over here. So we get m equals 1 over sine of pi over 3 times cos pi over 3 cubed. And let's work that out. So that's 1 over, that's sine pi over 3 is root 3 over 2 times cos pi over 3 is a half. So that's half cubed. So we can just work this out on a calculator. I think that's 1/8. So that's root 3 over 16, and we just flip it upside down. 16 over root 3, and we can just rationalize this. So that should become 16 root 3 over 3. So that's the gradient, that's our m. And now we need to get the coordinates of the actual point over here. So we can plug pi over 3 into the x and y formulas. So let's do that. So x is sine squared t. So x will be sine of pi over 3 squared. So that's root 3 over 2 all squared, and that gives us 3 over 4. So that's the x coordinate. For the y coordinate, we're going to sub it into y equals 2 tan t. So y equals 2 tan of pi over 3. So that's 2 times, and tan pi over 3 is root 3. So that's equal to 2 root 3. So we have a coordinate now. It's the coordinate 3 over 4, 2 root 3. So now that we have a point and a gradient, we can now get the equation of the straight line using y equals mx plus c. So we have y equals mx plus c. Therefore y equals, there's the gradient over there. So y equals 16 root 3 over 3x plus c. And then we're going to substitute the x and y coordinates in to here. So we get 2 root 3 equals 16 root 3 over 3 times 3/4 plus c. So we can just work out c. The 3's cancel. The 4 and the 16 cancel. So that cancels and gives us a 4. So that gives us 2 root 3 equals 4 root 3 plus c. So therefore c should be minus 2 root 3. So let's just write over here what the equation is. So we've got y equals 16 root 3 over 3x minus 2 root 3. So that's the equation of this straight line here. And in order to get the coordinates of P, that's the x-intercept, you have to set y equal to 0. So let's set y to 0. I can just put that here. So equals 0. And we can solve this for x. We'll bring the 2 root 3 over. Actually, we can cancel the root 3's first. Let me just divide by root 3 everything. They disappear. We can also times up the 3. So we get 16x minus 6 equals 0. So therefore 16x equals 6. Therefore x equals 6 over 16, which equals 3 over 8. And that should be, yeah, they wanted the x coordinate, so that's the x coordinate. X equals 3 over 8.